Hi everyone, this is Vishnu Priya working as assistant professor from the Department of Civil Engineering, and today's video is all about introduction to reinforced concrete structures. So as a part of my academic journey, I was teaching design and drawing of reinforced concrete structures. So if you see, the main objective of this subject is like to introduce the different types of philosophies related to design. So generally, if you see, we have three different types of philosophies related to design, and how the design philosophies will be working for the structural elements, will be helpful for the structural elements, okay, such as beams, columns, slabs, footings. Okay, this is the basic designs we get. Okay, so structural elements will be designed according to this design philosophies, okay, with the reference of the Indian Standard Code of Practice. So generally we'll be using IS 456 General Design Code of Practice for the reinforced concrete structures. Okay, so if you see the objectives of structural design, so the achievement of an acceptable probability that structures being designed will perform satisfactorily during their intended life. So okay, for every structure, for any kind of the structure, you have a certain life period. So it should be designed for the acceptable probability, okay, to perform satisfactory. Okay, so next, if you see what is the next objective, with an appropriate degree of safety, they should sustain all the loads and deformations of normal construction and use, and have adequate durability and adequate resistance to the effects of misuse and fire. So first of all, the structure is need to be satisfy the design conditions. Okay. Next, if you see the next objective, it should be uh, degree of safety it should provide. Okay, they need to transfer the load safely, and the deformations can happen and the deflections can take place, but within the permissible limit the deflection should take place, and it should resist all the uh, durable conditions. Okay, so what is durable conditions? That how the structure is performing for different weather conditions, you need to take care of that. Okay, so next, if you see the what is reinforced concrete. So concrete in which steel is embedded in such a manner that two material acts together in resisting force. Okay. So here reinforced concrete is something like you are providing additional strength to the concrete. So in the form of steel you are providing the strength to the concrete. Okay. So that what happens, steel is a separate material and concrete is a separate material, individual material. But when both combine and it is constructed, it acts as a single material, and that material will be resisting all kind of the forces or load acting on that particular member or structure. Okay, the reinforcing steel rods or bars or mesh absorbs the tensile stresses, shear and sometimes it also absorbs the compressive stresses in a concrete structure. Okay, this is the general definitions. If you see, when coming to the advantages of reinforced concrete, so it has high compressive strength as compared to the simple plain concrete. If you compare it, it has a high compressive strength. It has better fire resistance capacity than steel material. Okay, as an individual, if you see, steel concrete reinforced concrete has a better fire resistance. It need less maintenance as compare of the steel. Okay, it can cast in any required shape at site too. So if you see for the steel material, you have the particular like shapes and particular only like sections you have like where predefined sections. When as you say for the reinforced concrete, it can be casted in any required shape. Okay, so by using steel in concrete, cross-sectional dimensions of structures can be reduced. So if you only use for the plain concrete, you might need to use for the larger dimensions. If you incorporate like steel material into the concrete itself, the cross-sectional dimensions can be reduced. Okay. In some structures like advanced structures like piles or dam constructions, if you go with the steel with the concrete, it's more economical than going for the concrete or the steel. It's a combination of these two materials can have it more economically. It can be designed. Okay. So as discussed advantages, it also has some kind of disadvantages also. Okay, so when you see the disadvantages of reinforced concrete, it needs mixing, casting and curing. Okay, it takes a lot of time, so all of which affects the final strength of the concrete. So quality need to be maintained when you're mixing or when you're casting the concrete or when you're doing the curing process. Okay, So the cost of the forms used to cast concrete is relatively high. So if when you want a particular shape or dimension, you need to use formworks. Okay, that will be costlier. Okay, that amount, the what are the forms you'll be using for the casting of the concrete, that is relatively high. So okay, it has low compressive strength as compared to the steel. So individually, if you compare the strength properties, so if you see generally plain concrete and reinforced concrete and steel material, if you compare, reinforced concrete has higher strength when compared to the plain concrete. So steel material has higher strength when compared to the reinforced concrete. Okay, so cracks develop in concrete due to shrinkage and the application of live loads. So there's like, if like deflections are becoming more or deformations are becoming more, then it might leads to the crack formations. Okay, so you can also say the cracks also can be developed because of the shrinkage also. What is meant by shrinkage? If you see, shrinkage is the volume changes occurring in the concrete. Okay, because of that also there might be crack development. Okay, if you see the types of loads on the structures, so there are different types of loads coming from the superstructure to the substructure. So what is meant by superstructure? If you see elements like slabs, columns, beams, that and all comes under superstructure. Substructure means it comes with the footings. So how the load pattern transfers is like, it will be, loads will be transferred from the slabs to the beams, beams to the columns, columns to the footings, and from footings it will be transferred to the soil conditions. Okay, so if you see the some of the types of loads on the structures are listed in this slide. Okay, so first one will be considering is dead load, live load, wind loads, slow loads, or seismic, or you can say earthquake loads also. Okay, commonly known as earthquake loads. Okay, so types of loads. In this picture you can see there's like a combination of every load, like a dead load, live load acting on the walls, and wind load acting, live load, and snow load acting, and it is like seismic loads is like earthquake loads also can be shown in this image. Next, if you see what is meant by dead load. Dead load consists of self-weight of the structures, weight of the walls or floor or roofs, or weight of the columns, or weight of the self members, like members, structure members can be considered as the dead load. The weight of the foundations or footings and all other permanent loads acting on the structure is also considered as dead load. So these can be computed by finding the weight of the cubical content of the different materials used for the constructing the structures. So how you'll be calculating is like, if you say, I can say general example. If you want to calculate what is the dead load of the self weight of that particular beam, so you'll be taking, you know, what will be the cross sectional area. So in cross sectional area will be multiplied to the density of the particular material. What is the material we will be using here? If you are going with the concrete, you will be using unit weight of concrete. If you are going for the steel, then you will be using the unit weight of steel. Okay, so that is how you will be calculating what dead load or self weight of that particular member. Okay, so this and all acts as a beam. So you can see here what is the slab condition and what is the beam which is transferred to the column. This and all comes under the permanent loads, or like floor finishes, like floorings you will be using, that also comes under dead loads. Okay, next is live load. So live load consists of moving or variable loads. Okay, so that can be considered as people, we move on the floor conditions, or furnitures, or temporary stores, whichever you will be placing on the slabs or floors and all, that can be considered as live load. So this is also known as superimposed load. Okay, so this here you can see in this image what are the dead loads comes as concrete, steel, glass materials and all comes under dead loads. So live loads of people, furniture, materials on this in this buildings are considered as live loads. Okay, next is wind load. So wind load is like a force which is acting horizontal to the surface of the wall or roof, or inclined, which is acting horizontally on the inclined roof of the structure is considered as wind load. So that means it extracts uniform pressure on the structure. It creates a uniform pressure on the structural components, which tends to disturb the stability of the structure. So, okay, the value of the wind loads varies depending on the several factors. Okay, it depends upon the factor locations, geographical locations, and what is your structural height, and what is your flow of duration of the wind flow. It depends upon that. Okay. So here you can see how the wind load is acting. So on the wall conditions, or like on the inclined roof, how it is creates the pressure. Okay. So next is the snow load. The amount of snow load depends upon the various factors. Same thing, that such as like shape and size of the roof conditions. If it is like horizontal member, then the pressure will be, the amount of load will be more. Or if it is of incline, then it is different. And the roofing materials what you are providing, and where is the location it is like where it is constructed, and what is the insulating material you have provided, and what is the duration and frequency of the snow. So it depends upon the this conditions. Okay. So next, this is like example snow load, you can see.